What's up, everybody? It's Amy with the Breezy Broadcasters, and we're gonna do another chemistry project. Yay! First, let me just do a little disclaimer of why we do these. Well, one, we do this for a variety of different things. We notice that there's a lot of kids out there that love YouTube, and so this way they have a variety of good, clean things to watch. But two, I decided at a late age of almost 40 that I wanted to go back to school, and so we're just doing different video diaries of these things. Sometimes I have to turn these videos in. Today's not one of those days. I do have to take pictures, but I just thought I'd share my chemistry reactions with you. So my first experiment today is going to explain if it is endothermic or exothermic. Now, it does say to use safety goggles. These are safety glasses. I do not have safety goggles. However, they do protect my eyes, and I actually kind of get a double sense of it because of my glasses. Kids, if you want to do this, ask for your parents first. I have not done this particular experiment before. However, I do use these items when I do laundry, so I think it's probably not too unsafe, but you should always get your parents' permission first. Anyways, so the first exothermic question we have is by using vinegar, which I've already placed in this bowl, a half cup, baking soda, and a little bit of dish soap. And what we're going to do is we're going to make a mixture, and we're going to see if it's hot or cold to decide if it's endothermic or exothermic. So, for safety first, got the goggles. Alright, our first step says, in the first cup, measure 1 tablespoon of baking soda. 1 tablespoon of baking soda. One tablespoon of baking soda. Okay, and we're going to add a half a cup. Now, we've done this before, but we're going to add a half a cup of vinegar into this cup, and it says make sure not to inhale because any gas that's not oxygen smells like suffocation. But hopefully this won't smell bad, but nobody likes the smell of vinegar. So I've got my tablespoon of baking soda and a half cup of pre-measured white distilled vinegar. It asks if it gets hot or cold. And I'm feeling it, and I'm not feeling any temperature change whatsoever in this mixture, although we did see the reaction, and that's what we got. Alright, now for our second endothermic exothermic experiment, we need 3% hydrogen peroxide, dish soap, and activated yeast. So, in our first cup, what we did, we needed a half a cup of hydrogen peroxide, and in our second cup, it says squeeze a little dish soap into a cup, and a teaspoon this time. We're going to use a teaspoon. Can't see with the red on. It's 1 teaspoon of dry active yeast into the cup. With a half a cup of water. That water's hot, so it will kill the yeast. You kind of want to lukewarm when you're working with yeast. This is a quarter cup, so we're going to need 2. Mix it up, but it doesn't necessarily need to be dissolved. I guess I got a fork instead of a spoon. We're going to mix up the yeast, the water, There's dish soap in there. You can see it's bubbling, but it would do that if it was just plain yeast or with soap. Okay, so we've mixed it up. It does not smell very nice. Anyway, so we mix it up, and the dry activated yeast and I have to mix together. They dissolve. Place the cup of hydrogen peroxide into the sink and quickly add the yeast solution. So we're kind of going to do this backwards. We're going to put the hydrogen peroxide into the yeast. Right now this is kind of a warm, but that's because of the water, and then we're going to add the hydrogen peroxide. Picture. And I can tell you that this gets warm. So this one is exothermic, whereas the other one was endothermic. So this one's warmer. Alright, part 3 of our experiments today is making a polymer. And the definition of polymer is a substance that has a molecular structure consisting chiefly or entirely of a large number of similar units bonded together, e.g., many synthetic organic materials used as plastics or resins. The bottle from your shampoo and conditioner, polymer. Cling wrap, polymer. Ziploc baggies, polymer. And many other plastic items. Those are just a few that we have today. Okay, so in this project, or in this experiment, all we need is some cornstarch and water. And so we need to do 2 tablespoons, making sure it's dry, of cornstarch in a bowl or a cup or whatever you want to use. We're going to use a bowl that we've been using since this is a wonderful gift from my brother. Shout out to Uncle Andrew. Whoop whoop. Here we go. 2 scoops of, I'm going to rinse off my fork that we used earlier, of cornstarch. And we need equal parts, 2 tablespoons of water. It's not going to do anything very interesting like the last 2. It's not going to fizz up or anything. Cornstarch is usually used to thicken gravies, make syrups, stuff like that. We're going to mix it together like so. It does get very thick. Cornstarch, that's why it's a great thickener. It says 2 tablespoons of cornstarch and 2 tablespoons of water. Did I do 2 tablespoons of cornstarch? Because it says remove from the bowl and knead. And if it gets crumbly, to add more water. It says see if you can make this mixture into a ball. Observe what happens if you let the ball sit in your hand. I don't see how that could be a ball. So I'm going to go with no. I mean, it's sticky, but yeah, it can't make a ball. It's liquid. So does it stay in its shape or go back to liquid? Well, it never made a shape, so I'm going to go with it never made a shape. Alright, so the oobleck just ran through our hands. This one is the last one, and it's called oobleck putty, I guess, or oobleck putty. Anyways, again, we're going to use cornstarch, but this time we're using dish soap. Okay, and we're going to do the same thing, 2 equal parts. So it says 2 tablespoons of cornstarch, 1. I love that little thing that you could just scrape. 2. Okay, and 2 tablespoons of dish soap. 1. 2. This one's gonna be cool. And we're gonna mix around again with our soap. one's definitely a lot thicker than the last one. It says I'm supposed to be able to make a ball out of it. Well, it says, can you make a ball out of it? Let's see if we can make a ball. Try to work with a small portion of it and knead it into a small ball. I don't know about making it into a ball. I mean, it's definitely thicker, but it's not becoming a ball. Kind of feels like shaving cream. Oops. But making a ball per se, I don't know. I mean, it takes some form, but it does go back to liquid. So that's how you make oblate putty. But I mean, I guess if you just wanted to play with putty, it would be great. But as far as making a ball, So thanks for watching me, and play with polymer. But no, I wouldn't say it makes a ball.